Hello, GCSE question of the week, week 22, foundation first. Here are 4 number cards, A, B, C, D, the mean of the 4 cards. What's the mean? Okay, the mean's the one where we add them all up and then we divide by the number of things. The mean of the 4 cards is 11. A, B and C add together to make 40. A, B and C add to make 40. A is twice the size of D. The other 2 cards are the same number. Find the value of each of the cards. Right, how are we going to see our way through this? Let's start with that first statement. The mean of the 4 cards is 11. What does that mean? Well, we said, no pun intended, that means we take A plus B plus C plus D. We find the sum of A, B, C and D. And then we know that if we take that sum and divide it by 4, we should get 11 because 11 is the mean. Okay, so if I rearrange that slightly, that tells me that A plus B plus C plus D, the sum of A, B, C and D, if we multiply both sides by 4, gives me 44. Okay, and this is a good trick to know without even writing down that. If we know that the mean of these 4 cards is 11, okay, then the total of those cards has to be 4 times the 11. It's like a backwards mean question. Okay, so that statement's going to be handy. Then let's look at statement 2. A, B and C add together to make 40. Well, if A plus B plus C equals 40, either using some algebra or just by looking at those statements there, you can probably visualise that this A plus B plus C bit is that bit. And we know that's 40, so if we add the D, we get 44. D must be 44. Sorry, D must be 4, not 44. Okay, so how do we do that? We said A plus B plus C equals 40. A plus B plus C plus D is 44, so surely D must be 44. And again, you could write that using some more formal algebra. But D's got to be 4. A, next statement, A is twice the size of D. Oh, well, that's easy because we just found D. A is twice the size of D, so A equals 8. And the other 2 cards are the same number. Okay, well, we know that the other 2 cards are B and C. And we know that both of those have to be the same number. But we already know that A plus B plus C plus D equal 44. So let's think, well, A plus D, that gives me 12. And we know that A plus B plus C plus D gives me 44. And A and D make 12. So let's do 44 take away 12. That gives me 32. Okay, so why have we done that? Well, we said A and D are 12, added A plus D is 12. We can take away the A and D from here. We take away the 12 from here. Therefore, B plus C must equal 32. But we know that these 2 cards are the same number. So if we do 32 divided by 2, because we know they're both the same number, B must be 16 and C must be 16. Okay. Now, it's always a good idea to just check we've got it right. So let's just run through with our suggested numbers. A is 8, B is 16, C is 16, D is 4. Okay, do those numbers work out? The mean of the 4 cards is 11. A, B and C add together to make 40. So A plus B plus C, okay, 16 plus 16 is 32, plus 8 is 40, that one checks out. A is twice the size of D, well 8 is twice the size of 4, that one checks out. Other 2 cards have the same number, checks out. Let's go back to the top, the mean of the 4 cards is 40. Okay, well the total of them is 32, plus 8, that's 40, plus 4, that's 44, divide by 4, we get 11. We're all good. Okay, hi to your question. Here are 2 water tanks. This could be foundation as well. Here are 2 water tanks. So we got a cuboid water tank A, and let's look at the dimensions. 1.2 meters, 50 centimeters. Right, alarm bell should be ringing in your head already. 30 centimeters. And then we've got a cylindrical tank B with a 60 centimeter diameter. Not a radius, a diameter. Right, what are we going to do? Tank A is 3/5 full, tank B is empty. Half of the water from A is poured into B. Tank B is now full. Calculate the height of tank B. Okay, so we know that when we pour the water from A into B, B is full. So whatever water goes into tank B fills it up completely. Okay, but tank A is not completely full when we tip the water out. It's 3/5 full. Okay, right, but to work out how much 3/5 of the water in tank A is, we've got to work out the volume of tank A anyway. So let's start by doing that, which is probably what you would have guessed that you've got to do when you saw that question. Probably guessed looking at that, we're going to work at the volume of tank A. So the volume of tank A, that's the volume of a cuboid. Got to know your formula. What's the volume of a cuboid? Well, it's length times width times height. Doesn't matter what you call those. It's one dimension times the other dimension times the third dimension. Okay, right, now here's the first common mistake. We could put 1.2 times 50 times 30. But hopefully you're screaming at me that that would be a bad idea. And that's a bad idea because we've got mixed units. We've got meters, we've got centimeters, we've got centimeters. So we need all of those in the same unit to make this consistent. And it looks easier to me to turn everything into centimeters. So what's 1.2 meters in centimeters? Okay, I've got to times by 100, that's 120 centimeters. So a better calculation, and again, it doesn't matter which we call the length, the width, the height. We've got 120 times 50 times 30. Okay, now this possibly would be on a, yeah, looks like it will be on a calculator paper because we've got to use pi in a bit. Although we could use we could leave our answer in terms of pi. I'm assuming it's probably a calculator question. Okay, but we can do this bit without. Okay, we can do 12 times 5 times 3, and then we can multiply by 10 3 times, or stick 3 zeros on. So I think 3 times 5, that's 15. We could times that by 12. So we could do this. We could do 15 times 12. 2 5s 10. 1 2 is 2, and we could probably do this in our heads as well. 1 2 is 2, we get 3, put down a 0. 1 5, 1 1, we get 180. Okay, so if 12 times 5 times 3 is 180, then 120 times 50 times 30 must be that 180. And then multiply by 10, multiply by 10, multiply by 10, because we've got those extra zeros there. So I think we get 180,000. Oh, that's slightly wrong pen. Okay, 180,000 what? 180,000 cubic centimetres. Ignore the alarm. Now remember that 180,000 cubic centimetres is the total volume of this cuboid. But we know that it's only 3/5 full. So what should we do now? Well, let's work out 3/5 of 180,000. And I say it like that on purpose because as soon as I have 3/5 of, I now can change that of to a times. I'm really looking for 3/5 times 180,000. And how do we do that? Well, that's telling us that we need 3 times 180,000 and then divide by 5. Or you might prefer to think of it, well, find 1/5 of 180,000. Okay, that would be dividing it by 5, and then 3/5 would times it by 3, multiply by 3. Any of those approaches will work. Okay, so we could do this in our heads as well, or with some long division, multiplication, or multiplication division techniques. Okay, but it is a calculator paper. Okay, so question. We could do 3/5, and probably I wouldn't personally put that in a fraction. I'd do 3 divided by 5, but let's make it look exactly like it is there. 3/5 times 180,000. Okay, so we get 108,000. That's the volume of actual water in tank A. So 108,000 cubic centimetres, and that's water in A. Okay, how would I have done that with no calculator? Well, I think I'd have divided by 5 first. And divided by 5, I always divide by 10. That's easy. 180,000 divided by 10, that's 18,000. Okay, that was it divided by 10. Divided by 5, I know I can fit twice as many in. So I double that. That gives me 36,000. That's 1/5 of 180,000. Times that by 3, well, 30, 60, 90, 6, 12, 18, 90 plus 18, that's 108, and then I've got my thousands that I can just lump back on. Okay, I would have reasoned through it like that. Okay, but we can use a calculator. Okay, right. Half of the water from A. Right, so this is the water in A. We only pour in half of the water from A. So we need 108,000 divided by 2. Okay, that's going to give me 54,000. So 54,000 cubic centimetres is poured into tank B. Now for the tricky bit. Okay, so what do we know about tank B? Well, tank B is a cylinder. How do we work out the volume of a cylinder? Now, if you don't know the formula, you are completely stuck at this point. So you must know the formulas. Okay, so volume of cylinder, how we do that? Volume of cylinder equals, well, it's the area of the base area, times the height. And what's the base area? Well, the base area is the area of a circle. And the area of a circle is pi r squared. So it's pi r squared times the height, pi r squared h. Okay, so we know that the volume of this cylinder is 54,000 cubic centimetres because it's full up with water, and that's how much water filled it. So we can write an equation that says, well, that means that 54,000 cubic centimetres equals pi r squared h. Okay, that is the volume. Alright, now we can start lumping in numbers that we know. We can substitute. Do we know the radius? Yes, we do. Is it 60? No, it's not. The diameter is 60, so the radius is 30. Do we know the height? No, because that's the question. We want to work out the height. Okay, do we know pi? Yeah, it's about 3.1 blah blah blah. We can put it on our calculator. Okay, so let's write in the numbers we know. We know that 54,000 is equal to pi, let's leave it as pi on here, times the radius squared. That's 30 squared. I think that's going to give us 900, but let's put 30 squared times the height. Okay, if you're not sure, let's just check. 30 squared. Fabulous. It's got to be, hasn't it? 3 times 3 is 9. And we need to multiply that by 100, because we had 30 times 30, a couple of extra zeros there. Okay, 30 times 30, got to be 900. Now what are we going to do? Right, now we can say, well, if we rearrange this, then 54,000, I'm running out of space, all divided by pi times 900, that's going to give us h. Okay, so what do we get? We get 54,000 divided by pi times 900. Okay, now you could have used your fraction button, got it to look exactly like the fraction I'd written on the page. You could have done this in steps. 54,000 divided by pi equals, then divided by the 900. I want to divide by the whole of that denominator. Okay, so I needed the brackets in the way I've put it in. What do we get? We get h equals 19.1 to 1 decimal place centimetres. So h equals 19.1 centimetres is our final answer. Pretty confident, but let's have a quick check back. If we're right, then if we substitute that height back in to our volume formula, we should get 54,000 back. So let's try it. We're going to do pi times the radius squared times the height. So on our calculator at the moment, we've got the radius. Talking nonsense, aren't I? That's absolute rubbish. That's not what we've got on our calculator. Sorry, on the calculator at the moment, we've got our height. Okay, so we're going to do the height multiplied by the radius squared. That was 30 squared. We already know that's 900 times radius squared times pi. So fingers crossed, it's going to tell me that's 54,000. Fantastic. Okay, so a little check back. We know it works. Our height's 19.1 centimetres. Well done, as always. Right, go back, have a pause, try yourself, check through. Good luck.